This is a write-up that was recently posted on ctftime.org, and I thought it was pretty cool, and I wanted to show it to you. This was a challenge called Registry, part of the CTF Zone Finals for the 2024 game, and credit where credit is due, this is all put together by Keltec from the team Cat But Sad, I think in some leet speak there. I want to make sure all the credit goes to them. This is their work, this is their write-up, this is their experience in the Capture the Flag competition and this challenge. I did not play, but I genuinely think this is kind of a cool thing to showcase, so I'd like to walk through it and maybe do a little bit of demo if we can recreate a part of the challenge. The overview here, though, is that they were given an attack and defense challenge containing 5 different services. There was registration, a custom service written in Golang that would add or create things in a database, and authentication, where you can authenticate to the server with Docker based on this project csanta docker auth. And that is a full-blown open source project on GitHub, so there is a whole lot of code there, alongside the registry service that was the container images distribution server based on the official implementation of registry, also on GitHub. That is another ginormous open source repository, and it's official. It's the toolkit to pack, ship, and store and deliver container content. So there is a lot of hardcore code there, all meeting specific standards and, doing everything that it should. With that said, it's less likely to find vulnerabilities there, though not impossible. But for more things pertinent to the Capture the Flag challenge, they also have the image builder service. That is the custom service written in Python and Bash, used to rebuild and flatten container images, and there's Nginx in the mix to work as the reverse proxy, the actual entry point to all these internal endpoints. So the checker does specific things. The process or expected workflow is 1. Register a new account at /register, 2. Get an access token at /auth, and then upload or push a tarball with container image to the registry. The image is then processed asynchronously in the image builder service, and then would download the modified image and check for flag persistence. It does have an authentication policy that allows you to push, delete, or do whatever for an image if you are the owner. It's not possible to register another account and pull the checker's image by that. Now, because this is an attack and defense competition, not the usual kind of classic Jeopardy-style Capture the Flag game, they do have a service checker. And the objective, the goal here, the flag is actually in the checker image. That is what they're trying to track down. And there is one special account, an internal account called Service User, that's used in that image builder service, and that has access to all of the images. So ideally, Service User is what we're trying to get at. And you can see a lot of the permissions set in this auth policy. So if the objective is to just act as the service user, the admin account that has full access to everything, could we not just log in as them with their credentials? They would be able to download the checker image and track down the flag, but well, they don't really have credentials that we know. They are randomly generated at startup. With this syntax in this code here, it'll end up just creating random new credentials and password that the player doesn't know. So there are a couple different ways to go about this. You could bypass authentication by creating some crafted account that somehow matches the policy outlined in that auth policy YAML code above, or we could obtain some service user credentials. Those could be tracked down. If we could gain access to that account, then okay, we log in. Or you could create another user, some way, somehow, that has full access. Or ideally, we could get remote code execution in the service working with the registry or database. I really like this. I really like this sort of plan of attack, and I always love seeing when Capture the Flag write-ups include this, because you can see all the different sort of branches in your mind to go down and try to beat up and solve this task. It turns out, though, there was a little bit of a bummer and a boo-boo, an unintended vulnerability, or some of those unintentionals we tend to see in Capture the Flag games. Due to a deploy mistake, all the vulnerable boxes did have the same password set for the service user account. So that was probably generated during testing, and the distributed, not really changed with some specific value. So another player on another team did track that down, take advantage of it, and then end up using that for access. But that's not really what we want to dig into here. It's just a whoops, bummer, oopsie. The real vulnerability is something a little bit more interesting, and I think would be fun for us to walk through. So since they had access to all the source code, it is attack and defend after all, you have your own services, they carefully read the registration service, all the startup scripts, the database and Nginx configs, but those didn't have any clear or just egregious vulnerabilities, so they started to work in 2 different directions for their investigation. Another team member started to read the Docker auth source code in one of those big giant GitHub repositories, and then Keltec, the author of this write-up, started to examine the image builder service, since that was custom, homegrown, and it was a lot of bash code, and it looked a little suspicious. If it is a custom service for a capture the flag competition, you gotta think there might be some dragons there. Eventually, they came to the conclusion that the auth policy was doing what it should, and the Docker auth project didn't really have any vulnerabilities that they could leverage. But the build.sh script that came in the image builder service might have some runway, and they actually linked that for us to download so we can go play with it. So now, finally, that's been enough talk, boilerplate background context out of the way. Now we can get on keyboard, so I am over in my Kali Linux virtual machine. I'll hit Control-Alt-T to open up a terminal, F11 to full screen that, and I'll make a directory for us to work in. We can just call it testing. I'll move into that directory and I will wget down the link to that build.sh script and then actually have that downloaded for us to work with in a text editor of our choosing. I like to use Sublime Text. I'll hit enter on this, and this is the build.sh script. Now we can walk through this code, but there's some portions that I don't think particularly matter to us, because if we're trying to recreate this for just the sake of our learning, I don't think I'm going to go spin up and create an image service, repository, registry, all of that, but I would like to see, what is the real trigger that would fire or detonate that remote code execution in this structure? But before we go any further, please let me take a quick second to tell you about the sponsor of today's video, Snyk. When you're writing code, security might not be the first thing on your mind, but it should be. Vulnerabilities can sneak in from all over your code, libraries, or containers, and if you don't catch them, they can turn into real problems later down the line. And that is where Snyk comes in. Snyk helps you catch those vulnerabilities early and fix them fast without slowing down your development. And it's not just for your everyday projects. Snyk is also a super powerful tool for capture the flag competitions. Whether you're competing to win or just playing to learn, Snyk can help you quickly identify vulnerabilities, giving you an edge in securing your application and scoring points. Plus, it's completely free to try. Just use my link in the video description to get started. jh.live/Snyk. Huge thanks to Snyk for sponsoring this video. So they take in a couple arguments for command line arguments of the script. The $1, $2, $prefix in bash means it is a variable, and the numeric values 1 or 2 just mean arguments to the script. They have a couple constants set here, like the maximum layer count, and the service password that it's able to retrieve out of that file that it just saves and uses with some command substitution. So this thing ends up downloading an image called a repository to an image directory, where it'll actually put it locally on our host. That's why it's going to use make directory to build out the file or folder structure for that, and then it uses a cool tool called Scopio. I don't know if you've ever seen this before, but Scopio is actually really cool. It's a tool to work with remote image registries, retrieving information, images, and signing content, and it's totally the way to go when you do a whole lot of this Docker stuff or with a lot of containers and images. I've seen some of my friends use it, and I'm a little bit jealous because I think it's one of those that just makes you cool, you know? So they use Scopio to log in with credentials and then actually copy down or pull down the image, the repo, the code itself for a Docker container. Docker image, more specifically. And they use tar to, work inside of a specific directory, capital C, so it changes directory into that location, and the $image directory, the location that it's actually going to put all this, and it extracts the image directory.tar. Image directory was just the name that it gave it, but bear in mind the .tar archive means it is the saved image of the Docker container that would run. It is the image just bundled all up, including all of the layers that would make up the Docker image. That's very weird to say out loud. Finally, it would remove that tar archive and then determine the configuration name based off of the manifest.json that's included in the tar archive, and using JQ to rip through some of that JSON object, JSON, right, the JSON object notation, noting the root elements and their config includes that specific details. The config name would then be used to actually reference all of the layers inside of the rootfs.diff IDs, and we'll see all this come to life in just a moment. But it'll limit it to only 5, that max layers count we saw up above. If there are more than that, it will exit out. There are too many layers to work with, but otherwise, it starts to work with these layers themselves, once again extracting them with JQ. Beneath that, they have a comment here where they begin to unpack the layers. So they change directory into that folder and create a new one for them to work in called .overlay. Then they start to loop in a for loop, and they note for every single layer, let's carve out a layer variable that takes the given line that it's working through, and using sed to replace with some regular expressions. You can see the syntax there, S to substitute, G for global, where it will take the SHA-256 prefix, really, is what it ends up being, and replacing that in between these two forward slashes to nothing. We're replacing them with nothing, otherwise just deleting them, removing that context. So SHA-256 : goes away. And then they just display that out, echo so we can see it in action, and use tar to now change directory and noting we're working in the overlay folder, extracting each layer with tac overwrite. We increment and then we remove that layer so it unravels all of this and unpacks all of these individual layers. Within that code, look, let me move all this beneath it. We can make this our focus here. Let's try to zoom in on just this snippet. Do you see a vulnerability? Probably. At least I don't know if you've played some Capture the Flag challenges or you've watched a couple of these videos before. This tar command could very well use some tar command injection because the layer variable is not wrapped within quotes. And perhaps that's something that could be controllable or actually subject to whatever changes we want to make if we could manipulate some of the layers of this container image. Kind of neat, but let's see how they cover this in the write-up. They, of course, see the exact same tar command injection that we just did in this section here, where they unpack layers as part of that for loop in the code. And they note here, hey, for those who are familiar with bash exploitation, this is straightforward. The $layer argument in the tar command is not quoted, so it'll be split by whitespace and expanded to several arguments. For example, if that layer variable contained x space y space z, then the line becomes, and the command that's actually ran, is tar-c.overlay-xf, and then our input, x space y space z --overwrite. But the L variable that we saw in that loop as the iterator can't contain whitespace, because in bash, that for loop is going to end up using it to split up the layers variable. But, and I think this part is really neat, since there are calls to printf, they can replace the whitespace characters with the hex encoded representation, like \x20. To denote the ASCII character represented in hex, that 20 variable is going to act as a space. If we were to try that just as well, if I were to printf, then in quotes x and the \x20, same with y, \x20, and then a z, you'll see that it just prints that out, xyz, where the \x20 represents the space character. Gotta be honest, I think that's pretty neat, just a small tiny curveball and not what you would expect for classic cookie cutter command injection. And bear in mind that layers variable is constructed from the rootfs diff IDs array in the config file. And that config file itself is part of the image tarball. So if we were to upload our own crafted tarball with a custom array with any field that we might specify, we can inject that into the tar command. What that means is we build our own Docker image and then end up modifying its own config and those layers to have our command injection capability. And they do that with their own custom Docker file, where we could go ahead and do something similar from Alpine latest, and we can do just a run command to touch a file, temp/test. And I like to set the syntax here to bash, so we get a little bit of syntax highlighting. And then we can go ahead and build that image with Docker. We can use Docker build tact like my_image with a period to denote the current directory in the Docker file there. Now, I realize I'm using kind of an old Docker version here, but that's fine. Now I can go ahead and Docker image save the name of my image that we just called my_image and redirect that to an image.tar file. Do this, and now we have that image.tar archive that we would have all of the layers built and bundled and wrapped up into this file. If we were to make our own .overlay folder now, and if I were to copy that image into that directory, let me use tar to extract it out, xvf. I like to extract with x, v for verbose to list all the file contents, and f to specify the file with our image.tar, and that will give us all of this output. But I will note, I'll get a little bit of a different file structure than what they see in their write-up. And this, I think, gets into some of the changes that have been made with Docker and their versions as to how often they'll use the OCI format and that structure and layout for their containers. What I mean by that is if you go back to the write-up, you can see their resulting tarball actually has these folders, blobs, blah, SHA-256, and then all the SHA-256 sort of ID or hash values to denote each individual layer. We don't have that in ours. We have these SHA-256 hashes with a version, JSON, layer.tar inside of each of those, but we don't have the blobs directory. We do still have the very same manifest.json, and that will include the config value, but that's going to be different than ours because we won't, again, have that blob SHA-256 prefix. Let me show you that. If I were to open up my manifest.json, I like to use a pretty JSON extension in Sublime Text to then format that JSON. You'll see the config value is going to be at this location, but that's just a .json file given the SHA hash, not in the blobs file structure and folder location that they do in the write-up. Now, I'm going to be completely honest here. I've been trying for a little bit of time now. I poured a couple hours in this trying to prepare the video, the demo, and showcase. I wanted to try to actually get that version of Docker where it will naturally use the OCI format to display and render and keep all the tar archive structure the very same, but I haven't been able to get that working. The Docker image save command, I tried to see if that would actually have any options to specify the format, like if it would use the OCI layout. That didn't seem to have any runway for me. Trying to downgrade or uninstall and then reinstall Docker with whatever version, if there were one, like 18.09 to actually have that structure, didn't seem to work all that well for me. I was wondering, can I run Docker inside of Docker? And that's apparently possible, by the way. You can do a dind, D-I-N-D thing that lets you do that. Like if I were to try to build a Docker file. Let me make another one here. I can just make a directory for dind. I'll cd in there some Docker file that I would like. You can do like a from Docker and then whatever version you want, 18.09, I think might have been the one that was supposed to have some of that access, but the -dind will actually let you do Docker in Docker, and I never got that working. At least, I don't know if I needed some C groups or whatever other special permission stuff that it does or needs. And I know you can do it with like Scopio or Builda, but those didn't end up having the manifest.json file that we really would need. This ended up giving the actual .json file that we could very well use from our extracted rendition here. Like if I were to subble that JSON file, again, format printing that, we could scroll down to where it would tell us some of the stuff like the root fs diff IDs, but these SHA-256 hashes that it's working with don't actually exist as directories or locations to work with on our file system here. You can see our extracted one has 45 E3, CD25, whatever, not matching 7565 DEE4. Now, I don't know OCI format, spec, layout, structure, and all that, but I'm thinking we're going to run into a wall, so I will probably just nerf these out or play with it as we should as we get further in this challenge. Because as we now know, that .rootfs.diffIDs array inside of the config file JSON is actually where we have our command injection opportunity, just in these entries here. So they go ahead and add something as a simple proof of concept, right? That SHA-256 prefix that we know gets truncated out from the, or whatever, removed, just that prefix gone away. With that said, regular expressions find and replace, where they use the \x20 for the hexadecimal representation, and they end up building this out as a new packed image in tarball and then pushing it to the registry that they have set up in that environment. Now, we don't have the registry service to poke at and play with in our example, but they did link this cool resource in case this is ever helpful for anyone ever. A little bit of a Python script they uncovered on GitHub. Docker push or Docker pull push by S. Dinell or Dinell Simon over on GitHub. Kind of neat. Looks like a Python script to pull images from a Docker repository without installing Docker and its daemon. It looks like you can push to repositories just as well. I gotta say, I think that's the value of reading write-ups because you'll find other tools and utilities that you might not have seen before. At this point, it's basically as easy as using one of the GTFO bins or other tricks and techniques that you could use with any natural native Linux binary. tar, of course, being in the resource list here. If we wanted to go track it down, we could search for it, and they reference this in the write-up just as well. But using the tar command, you could gain a shell. Looks like it has a couple opportunities, tricks you could use, but they note this only works for GNU tar. one specific version of the utility. And just that tiny difference did seem to make an impact in the actual game. The real capture the flag challenge, they note, hey, let's go through the usual GTFO bids, try off one of those remote code execution payloads. All the ones that we just listed, we got to see in the moment, but it didn't work because they were dealing with a different non-GNU version of tar. The image builder service was using BusyBox, that binary that has a lot of the core utils, command line utilities all packaged in with there. So their tar has only the following arguments. Everything that it saw above, but not some of the tricks that GTFO bins covered. So to get us in that environment where we might be able to use exactly that, let's actually get ourselves into a Docker environment, as weird as this might be, but let me Docker run attack IT, and let's use the latest rendition of Alpine. I'll do that again, with our bin bash as a program to run. Oh, it doesn't even have bash because it's that slimmed down. So we'll run bin sh, and that will get us into Alpine, which should have tar, in which case the exact same output that we saw just a moment ago in the write-up using the BusyBox rendition of tar. Now, if we wanted to work with some of the files here, and I realize that I am root, so this is very contrived just for the sake of showcase, demo, and learning here. If I wanted to get a text editor just to be able to work with stuff, let me apk add nano, and that way I can at least work with files in a text editor. But now we could use the same script that they had, get us through that unpack layers loop, and see if we can get the injection point as they did. Because they started to get a little bit clever. They realized if we don't have some of those command line switches and flags and parameters to do an easy, nice and quick remote code execution opportunity to pop a shell, well, you could maybe still just craft a tarball with another file inside of it that could give them more capability, like overwriting anything else, like an arbitrary file write. And they do that really smartly to, clobber what would be the Scopio syntax, trying to end up modifying a binary with their own custom binary or shell script, or just totally clobbering the authentication policy in that authconfig.yml. So that way, the syntax that they use for their command injection actually extracts a tar archive included inside of the container image and that specific tar archive, so that then they could clobber whatever file they wanted to. For our sake of showcase, maybe we could just mess up etc. shadow and create our own service user to kind of simulate this just as well. So just for funsies, let me try to see inside of an Alpine Docker container, what does the etc. password or etc. shadow or whatever you want to clobber. In this case, we'll use etc. password because that way it'll be able to grant us with a new user. Let me copy the syntax, or at least all the file contents here. And now I'll go ahead and put this inside of a new file where I'll copy a root user identity. Honestly, we don't even need it. We could just kind of clobber that and say service user can be the one that we want as our new name here. And we can call this inside of a new directory that we'll make like etc. and kind of mask and create the same sort of structure. Let's just call this password, PASWD. Now we could actually open up our file explorer, and I'll open up a different terminal here to move into Thunar. I'll just use that for a quick and easy way to create an archive of our etc. directory. Can I right click this, create archive? Kind of a cheat, I know using the GUI, but that's fine. Let me make a .tar. And I can call that just our payload.tar. Now, if I actually go examine our payload.tar, it has the etc. folder in there and our password file that has our new service user account to clobber the root user. Again, just for the sake of showcase, demonstration will have code execution and validate we are running now as that user. In fact, actually, we should remove the password. We could just kind of remove the X in here, and we'll have to rebuild the tar image for that, but let me do that super quick. Just so we could sort of demonstrate having an account created or making some difference that we can easily control, we could just switch user into the service user that has power and privileges. I know different from the CTF game, but worthwhile to showcase here. Let me rebuild that archive file for us, payload.tar. Now this might get a little complex, but bear with me. Let me exit out of our current playground Alpine Docker instance that we use just to get the BusyBox tar version. So I'll get back to my regular terminal, and I want to create a new directory for us to work in so we have a clean slate. And I am going to actually copy my payload.tar into that clean slate because I want to have that build out a new Docker file, a new Docker image for us with the same sort of structure that we would see in the write-up. Following through with their idea, right? Creating our own custom tarball from simple Alpine latest, where it adds in their payload. So from Alpine latest, where we add our payload.tar file. Actually, that'll be in this current directory on the host, but we'll want to put it in the root of the file system inside of our Docker container, right? That looks good. Now, back in our terminal, we can docker build tact target, that's fine, with the current directory as it knows to add in payload.tar as one of the layers of the Docker image that we've made. Now, if I were to save this, just as I had the other one, docker image save target, redirect that to our target.tar, so we have a file encapsulation of the Docker image. Let's extract this all out as we have done previously. And you know what? Maybe that's better in like an inner folder for us to keep it clean. So we'll actually move the target into inner. And let's have this all extracted so we can see the layers come apart. There we go. Now remember, it followed through from our build.sh script where it first took a look at the config file via the manifest.json file. So let's open up that one for this. Determine the config location, which is the .json file that it will reference. Let's open up this one. And now, let's format that pretty JSON so we can work with it. And the rootfs diff IDs that we'd use for the SHA-256 hashes, they had been able to keep these values in there because it referenced the same hash values that were present in their directory. Not the case for us, so I'm going to simply rip these out and then have the same sort of injection point as they did with SHA-256, and now whatever we want to fall into the layer space, when it's actually working through this for loop to unpack the layers, right there. And the write-up is very clever here because they know all of the innards, the layers and contents is already extracted into .overlay. So they could very well just reference it, but then tell tar to extract it out to the root of the file system, the single / here, using the exact same tar payload that they just crafted. So if we could get smart, knowing how this is all coming together, we could determine which of these layers, given the random name that we're starting to play with here, actually has the layer.tar file that contains not the entire file system of Alpine, because that's not really what we're looking for. We're looking for our payload version that will contain our payload.tar. That's already extracted out in their case, but in our case, we want that etc. password. This works very smartly in their scenario, but won't work as easily in ours, so we're going to have to do a little bit more hand-holded guiding and sort of break the illusion, really. But the file that they have, their payload.tar, is already present in overlay because it came from the previous image layer that was just extracted in that loop. So that command will then change directory to the / and then extract it. Since we had the weird inconsistencies of like the layer values not matching up because of the OCI format nonsense, the only way for us to like cleanly do this in the showcase demo, Cooking Show Magic, is to have two different SHA-256 entries here and have it run two different commands. But it is command injection and there's really nothing stopping us from doing that, so maybe that's even cooler, not gonna lie. We could see from our file explorer that the FAFD whatever SHA-256 hash is the one that has the layer.tar. So let's extract that out first, and we'll actually need to be very explicit there, layer.tar, and that will end up extracting, as you know, our payload.tar into then the current directory. But now let me see if I can get this right. Kind of crossing my fingers here. \x20. We'll use two backslashes here because we are inside of double quotes, so you need to escape that out from what would be the \x x20 representation. For the white space or space character, we'll use tac-c to change directory again, now with our /, given our space character separating these. Following that, we'll want to extract -xf space again, and that will have the payload already extracted into the overlay, and it will end up adding on the .tar file extension at the very end. So I think that would work, right? Maybe? I hope? We can try this out by getting whatever portion of the build.sh script that it would do to try to match the same sort of structure. So let me copy all of this code, at least getting to the unpack layers segment. And let's see if this syntax is something that we could end up firing and running as if it were in the context of the image builder service and all this of the CTF challenge. So image directory is not going to be an argument that we'll pass in. We'll just paste this into our prompt and we'll basically be operating from the current directory that has the layers already downloaded, so to speak, and ready for us. The max layers count we don't need to worry about. The service password we don't want because that's not going to be there. We're not going to download anything with Scopio. We're just going to end up having, layers extracted as they did already for us. Actually, we could keep that so that way it'll do the extraction for us and that might make it easier. So rather than, our clean slate, maybe we could play on that and just call that our dirty image that contains our payload. And we should, at that point, actually create the image directory folder for us. So that means all that we need to have is our target.tar file that we built out be renamed to our dirty image and put this into our Alpine container for us to work with. We don't need to worry about the too many layer count crap. We do, of course, still want to extract out the layers and base layers, and then we'll actually keep the loop, of course, that does contain the vulnerable tar command injection point. So I think this is everything that we need to actually fire and run as if it were the image builder service. Let's go ahead and put this together. This means, though, that all of the changes that we've just made to the layers in the inner subdirectory, of course, modifying the layer configuration and all that stuff, we can get rid of the old target.tar, but that will need to be its own new dirty image, right? So let's get everything here inside of there and let's create another archive specific for that. That should be our dirty image.tar with the payload present. We can move that to the parent directory here. And then I think we can use our old Docker run Alpine latest bin sh, and let's actually mount with TACV the present working directory over in /app. That's fine first. So we have a place to work with our current files here. Now, once I am inside of that, we can apk add jq. So we have that as a command to run for us. We should probably do the same for bash just in case, because I do want to end up using that specifically. And if I take a look at the current value of etc password right now, let's see if running our script, once I get into app and see that our dirty image.tar file is there, tar should extract all this as we would expect, just making sure that this make directory image dir command is there for us. So now I can copy and paste all this and we'll paste it in to see if it will work. Hit enter there and there are no errors. What does etc password look like? Did it work? Not quite. What did our command do? And I'm actually going to delete that rm image dir.tar because I want to keep that just in case we go wrong. So let's try this, and let's see if the for loop will echo out anything, and it didn't. So I don't know if it even got to that layer for some reason. Is it only doing the first one for whatever reason? What is in .overlay right now? Nothing. It didn't echo anything, and it didn't do anything else. So did dirty image do anything that it was supposed to do? The 5d.json is the one that has our payload present, but it never extracted out any of them. So I want to step back. Let's make changes to what would be the config file with these diff IDs. SHA-256 could do even the first layer to start with. That's probably fine because it will extract those out and we'll add a comment or a comma at the end of that. So that should be built, correct? Let's remove the old dirty image.tar. Let's bundle up all the changes that we just made with our config file to a new dirty image.tar. Let's bring that back up to the clean slate so it is back in the current directory inside of our Alpine container. Let's get back to our script and Sublime Text so we can copy and paste this in. Fingers crossed, once I hit enter, we should see it echo out a layer. Why can't you open the payload.tar? How did RM get a TAC-C there? What is in overlay right now? Nothing. Why? What is in FA layer.tar? That is that. Can I tar that file given .overlay /xf? Yeah! Oh, it makes it a directory. So let's cd.overlay payload.tar, and that's our etc password file, and that's our password file. Okay, so because it makes a directory, I wonder if we could just switch that up. And the first tar like didn't even extract as we thought it would. Or at least it deleted it. Oh, that's why. It went to RM because it's going to end up deleting itself as a layer. I see. So it did have this extracted. It just removed it. Could we not just do semicolons? Let me printf semicolon that? Like, would that work in a loop? I don't know. Worth a try. Could we make this like the copy command with using our spaces, with payload.tar being apparently a directory that it makes, etc password to our real etc password, and then semicolon, and like it could be anything .tar because we'll add on a .tar extension at the very end, remember? That can error, that's fine, as long as these other commands succeed and run. I'm very sketched out though that the rm command will then eat that and remove it. Let's try it. It's all in Docker container. It's fine. We can mess around. Remove old dirty image. Get rid of the other one in our Alpine image. Rebuild all this. And let's copy this again and see if this one will work. I hit enter. Tar cannot open layer.tarcp. No such file or directory. All right, so I totally broke our actual etc password. Let's make that again. No! Forgot to add nano in this instance. Put this back and make that the actual root user. This is dumb. I'm all over the place. All right, I feel like this is really falling apart and not what I thought it would be. So I think we could restructure this just a little bit again. The payload.tar, as we know, would have an etc password file treated as a tar archive outside of the instance. But that didn't seem to work for us because it ended up having the payload.tar as a directory. So I think if we were to create a different tar archive that is really going to end up being a folder, well, that would mean that our password file is on its own inside of a repository. So let's create the archive calling it etc.tar, as simple and as stupid as that would be. But then etc.tar would be what we could put back inside of a different Docker instance. So what used to be our payload.tar is now just going to be our etc.tar, putting it into /etc, right? Will that work? That means we would have to totally change the layers again, build something entirely new. That means we would have to get rid of the inner folder and start entirely anew, because that is all old now based off of the other image layers. So I kind of want to keep this syntax here, but I want to start anew. Let me delete inner and then docker build tact anew based off of this directory. By docker image save anew to that tar file. Make directory inner for us to work with it. Let's actually move our anew into there. Extract again. Thunar to edit this. We should know and see that this layer, that's the one with Alpine's file structure, so we don't need that. 80db is the one that has our etc folder and a password present. So modifying from our manifest.json file telling us cb9.json is the config, cb9.json. Let's format JSON that. Let's clobber what would be these layers. Change this to actually represent the 801 to denote the layer. And that layer.tar is going to be its own payload. So we really aren't doing any more of the tar command injection. So man, you know, I feel like we lost the plot here. Whoops. Maybe this is a bust because of all the differences. Let's see if it would work anyway. Because at this point, I'm scraping at straws, I guess. So let's get a new .tar out of here. Let's put this all together in what would be our final, hopefully, dirty image .tar. Let's drag that one up to our clean slate where a new can go away. Let's grab the actual vulnerable code. Now back in our Docker container, we do have etc password back in action because I restored that. But if I paste all this in and I hit enter, Oh, it added a .tar extension. I'm an idiot. Remove that. Rebuild all over again. Clear the screen. Try it again. Hit enter. No errors, but what does it set a password look like? Gosh darn it. No, it'll end up extracting it there. We still need the command injection, right? It'll end up putting it in the overlay directory, but not the root of the file system. So we still need to do this with the /C to move into a different directory, but now actually use that layer piece that is a tar archive. So that'll still extract. Like that should be the root of the file system, and then the \x20 to then extract layer.tar \x20, paste that in, and it will append on .tar again, right? I think. Let's try it all again, and at the very least, we've got a fun showcase of me fumbling around and experimenting. So, dirtyimage.tar, grab the code. Dang it, had a typo. That should be called dirty image with an I. How about now? Okay, paste the code. Enter. RM didn't work, which is fine. R should have, and it should have put it now in the real etc. password. Yeah! That was stupid. Why did I make that so completely bastardized off of what the write-up was? But theirs, I think, makes even more sense now because it would be part of the layer itself, right? It's there from the others, but because we didn't have the exact specific names in our structure because of the OCI format, I think, please let me know. Genuinely, I'm happy to be schooled here. I think, at the very least, the real value for this video should be the write-up. Like, and again, all credit where credit is due. This is Keltec and his write-up with the Cat But Sad team. But I had a lot of fun tinkering with this because I thought, ooh, this could be recreated with enough of the walls that I ran into and banged my head against. Still, having the full-fledged environment where you have a genuine actual Docker container repository and registry and things that are all there with that format and structure, that's neat and very, very cool. So big shout out, big kudos, big credit where credit is due. I'm falling apart now that I've been trying to wrestle with this for quite a long time, but I think we got it. And hey, thanks so much for watching. Thanks for tolerating me fumbling over the keyboard and failing and flapping about. But I hope it was fun. I hope you learned something. I hope you got to see the big picture really based off of all this. Again, I thought the printf trick with the hex encoded 20 there was kind of neat. I think the little bash command injection was not something that you would easily see, all within the context of the custom services and Docker containers all in the mix. So just genuinely, I thought kind of a cool thing. Thanks so much for watching. Hope you enjoyed this video. Please do all those YouTube algorithms, like, comment, subscribe. I'll see you in the next video.